Good afternoon and welcome to today's webinar, PNT Executive Order Update 2021 Actions and Priorities, hosted by Orolia. My name is John Fisher. I'm the VP of Advanced R&D here at Orolia. And to mark the 1 year anniversary of the PNT Executive Order, we felt it would be appropriate to explore the latest developments in protecting the national U.S. critical infrastructure from GPS jamming and spoofing and interference. So today we are fortunate to be joined by excellent speakers from 3 different organizations. From DHS, we have the U.S. Department of Homeland Security. We have Ernest Wong, the Technical Manager at the Science and Technology Directorate. From NIST, the National Institute of Science and Technology, we have Jim McCarthy, the Senior Security Engineer for the National Cybersecurity Center of Excellence, and Yaxian Li Baobao, Computer Scientist at the Cyber Infrastructure Group. And from the Joint Base at San Antonio, we have Jerry Trevino, the 5G Network Engineer for Cybersecurity. So before we get started, I have a few housekeeping items to cover. Number one, this webinar is being recorded. So for those of you that are unable to join us live today, there'll be a recording available to you. You may submit questions during the meeting through our question panel that you see on the right. However, many of you have already submitted questions at registration time, so right now we have plenty to cover. So, but our speakers will answer as many questions as possible and during the Q&A, and possibly if we're not able to address some of them, we can do things by email later. If for some reason you lose your connection to the meeting, you can join again using the same meeting link that you had before. So our agenda is today, Ernest will kick us off with a holistic approach to PNT resilience. Then Jim will introduce us to the NIST PNT Profile, aiming at applying the cybersecurity framework for responsible use for PNT services. And then that'll be followed by Jerry, who will present the latest on U.S. military capabilities enabled by 5G and PNT and how they are addressing resilient PNT and their critical infrastructures. Lastly, I will give some updates on Orolia's recent activities in this, and then we'll finish up with our question and answer period. So a lot to cover, but first let's do a quick poll question. So we'll come up with this poll question, will be on our screen, and there we go. So prior to this webinar, were you familiar with the executive order and the work of DHS toward a resilient PNT framework? So please pick one of these, answer with just one of these thing there. If no, you weren't familiar. If you were a little familiar with maybe the exec order, but not the DHS work. If you're either maybe familiar with DHS's work, but not the exec order, or familiar with both. So if you could make your entry, we'll give you a few more seconds to make your entry, and when we've got a full amount, we'll see. And we're asking this question so that actually our presenters can have an idea of the audience that they're talking to. If most of our audience is not familiar with things, they'll try to give a little more background. But if you're already familiar with it, then they'll give you more. So what do we have here? It looks like we have a pretty good mix of folks. About a third not familiar at all, a third at least familiar with the exec order, and about a third familiar with both. So it seems like we'll we'll at least now have an idea of what our audience would like to hear. So Ernest, I'll turn it over to you, and looking forward to hearing your presentation. Okay, Ernest, looks like you are unmuted. And there we
Great.
go.
Thanks, John, and good morning, all. Before I get started, I would like to thank Orolia for inviting us to this Orolia Coffee Talk webinar. And it's also my pleasure to be on this webinar with the other presenters, Jim McCarthy, Yushin Lee Babu, and Jerry Trevino. Now, this presentation will be focused on S&T's approach to PNT resilience and the resources that we're developing and releasing to help facilitate that. But before getting into that, I would like to review the PNT Executive Order, EO 13905. And the core concept behind this PNT Executive Order is this concept of responsible use of PNT. And that definition is taken straight from the EO in that first bullet. But in summary, our responsible use of PNT is having this risk-informed approach to looking at where you use PNT and how it's used downstream in your systems, so that you can then assess and limit the impacts of potential disruptions to your operations. And so that assess and limit component are quite key to responsible use. Jim McCarthy is going to be talking later about the NIST PNT profiles. Those PNT profiles serve as a risk assessment and management tool that can help with this responsible use of PNT concept. And as far as limiting and mitigating the impacts of PNT disruptions, that's where a lot of the DHS resources come in, including the Conformance framework, some of the reference architectures that we're working on, as well as some other products I'll be talking about. But when it comes to limiting those impacts, that's where you need to look at how do you build PNT resilience into your operations. Right. Now, the next 2 slides, I'm going to fast forward a little bit in the interest of time. I believe from that poll, most of you are probably quite familiar with this space already in terms of how GPS is this invisible utility that enables a lot of critical infrastructure applications. So I won't belabor that point. Now, when we look at the problem of PNT interference and disruptions, oftentimes we talk about, and I'll use GPS as an example, we often talk about the issues and increasing prevalence of GPS jamming and spoofing, and the impacts that that can have on critical infrastructure. And that's normally where we stop. So I'd like to go a little further. Oftentimes you'll hear various government officials talk about how we're trying to make the point that GPS receivers are really more like computers and radios. And so going along with that, when we look at GPS receivers, they are always listening, always ingesting, and always processing GPS signals and data. And if we look at it from a cybersecurity perspective, this is the equivalent of an open port, which are major vulnerabilities in computer systems. So those need to be addressed. Now, there is an emerging trend which kind of makes this problem worse, which is in the past, when we talk about this, when we look at it from the perspective of open ports, in the past, you just have one, GPS. But now and into the future, there is this industry trend of having more and more sources. You have multi-GNSS as well as non-GNSS sources available. And there is certainly value to having all these other sources, which allows you to do things like anomaly detection, do comparisons across sources to look for consistency, and also provide continued solutions in the event of some disruption to one source. And so that all has value. But it's also important to recognize that as we introduce more and more PNT sources, we're also introducing more and more attack surfaces with all their associated vulnerabilities. And so that has to be dealt with. Just a bit of a latency on my end, so excuse that. So what do we do about this? So this slide is really kind of the main slide that goes over what is S&T's approach to having a holistic solution for PNT resilience. And there's 2 assumptions that come with how we approach this. The first assumption, which I already alluded to, is that the future of PNT most likely involves a multitude of PNT sources. And every PNT source needs to be treated as an attack surface. The second point is more about how do we deal with these vulnerabilities. And normally the process involves doing a bunch of equipment testing across different types of equipment to understand what are the vulnerabilities in different types of implementations, and then developing mitigations and deploying or transitioning them. And then we have to wait for the new acquisition cycle to actually get that new equipment. And so this process is quite slow, very expensive, but most importantly, it's just not scalable. Right? When you start adding more and more sources, trying to do this for every single source just becomes cumbersome, and it's not scalable. So when we look at the next generation of resilient PNT, from S&T's perspective, we see a couple different requirements for enabling that. The first is that you have to assume that systems will be attacked and to design them in ways so that they can withstand and recover. And that withstand and recover feature is really the essence of resilience. The second is that when we have so many different PNT sources and a multitude of different threats, we really have to have more agnostic approaches to how we deal with threats, so that it's more of a we can future-proof it, and this has a lot to do with how we design the architecture. And last would be borrowing some elements of cybersecurity, especially with how we look at trust or distrust. And so these architectural elements that we see, first is when it comes to attack surfaces, we need to minimize and harden them to the extent that we can. That's the most basic thing, but there's a lot more to it. So those attack surfaces are the interfaces that touch the external world. And so those should be our most untrusted components in our PNT systems. And we have to distinguish that from the components that we do trust. And then think about how do we pass data securely between all these different components and interfaces, while also ensuring that we have some degree of separation and isolation between all these components, so that one, for instance, different PNT sources don't cross-contaminate each other, and two, that the untrusted components don't taint our trusted components. And then next would be looking at it from a perspective of what do we really trust in our PNT systems. So currently a lot of PNT systems would have the GNSS sources as their primary source, whereas we would propose the oscillators, your holdover devices, whether it's oscillator or IMU, should be your primary device or your primary source, and you protect that source and all the data associated with it, and only discipline that holdover device in a very controlled and deliberate manner in terms of knowing when and how you reach out to the external world and bring back that data, so that you can then continue to discipline the oscillator. And then last would be this recovery capability that I spoke about in terms of being able to recover from any sort of attack, because that is something that isn't necessarily the case with current equipment. So DHS S&T has been developing a number of different resources in collaboration with our other DHS component partners, such as CISA and policy, to help facilitate this approach. So the first one is the Resilient PNT Conformance Framework. And it seems like perhaps only 1/3 of our audience is familiar with that. There'll be links at the end of this presentation if you'd like to learn more. But this is a framework to define how we expect resilient PNT devices to perform. And this is something that we've developed with a number of our federal agency partners as well as industry. And this is something that we've been talking about over the past 1 to 2 years to solicit input. And this is a PNT source agnostic framework. So it's not specific to GPS, it's source agnostic. And it's also outcome based. So it's not prescriptive and is really meant to be outcome based to encourage innovation. Now this framework, because it's outcome based, there are some constraints in what can be included in the scope. So it doesn't include everything I spoke about in the prior slide. So to address that, we're also currently working on resilient PNT reference architecture, which is looking at a more concrete explanation of all these different concepts I spoke about previously. And this will essentially be the finishing touches to the conformance framework. We also recently released the PNT Integrity Library at the end of February, and we have an enhancement on the way to add in GPS whitelist data spoofing protection. But this Integrity Library is an end-to-end GPS spoofing detection suite, and it's also a modular API. So if you have your own detectors that you'd like to add, you can do so, and it'll provide you a weighted solution, and it's essentially plug and play. And this is open source, free to use, and you can download it from CISA's GitHub page. Again, links later in the presentation. And the purpose of this detection suite is really to help enable some of the requirements in the conformance framework that involve preventing corruption of your PNT sources and things like that. So we're trying to release various resources to help facilitate all these different concepts that we're talking about. So next steps, the conformance framework was released back in December of 2020. And we have released a project authorization request to submit a PARD, IEEE, in February for development of voluntary standards. So once this happens, it will become an industry effort. A decision expected in late April in terms of whether they will approve or not. And if approved, most likely there will be some sort of working group set up, so under IEEE. So if you're interested in this, I would suggest to keep an eye out and get involved. And reference architecture, which I spoke about, that'll be a companion document that fleshes out all of the resilience concepts that I discussed earlier. And we're currently working on this and planning to have it ready for a presentation later this fall. So one of the questions that often comes up is, what is the difference between the conformance framework and responsible use of PNT and the PNT profiles? So the conformance framework is very much focused on the systems that deliver PNT information. So these would be your chipsets, integrated receivers, those sorts of things. And the purpose of the framework is really to facilitate the development and adoption of these resilient end user systems that output this PNT data. Whereas the PNT EO, the responsible use of PNT, is really about the whole entire PNT ecosystem, including all of the downstream applications in terms of how you use PNT, where you're using PNT, what your dependencies downstream, and all of those other factors that you need to take into consideration when you're looking at this from a risk-based approach. And also a final note here, the PNT Executive Order, DHS is also working on drafting vulnerability test plans per the Executive Order. And later this year and into the next couple of years, we will be working with critical infrastructure operators to assess or help them assess the vulnerabilities to PNT disruptions. And the results of this will help inform future updates to profiles. So this is the resources slide, a number of links here. The biggest one, if you go to gps.gov in the lower right-hand corner, there is a link titled Responsible Use of PNT, and I'll take you to a resilience page where it covers a lot of different federal products. If you're interested in the things I spoke about here today, you can check out these particular links here. And you can also see our program pages at DHS, S&T, and CISA at these links. So that concludes my presentation. And thanks for your attention. And John, back over to you.
Thank you, Ernest. That was great. And, you know, it's somebody like me for a novice in cybersecurity, that was really helpful to see, you know, thinking about attack surfaces and open ports, and it really resonated with me. So thank you. We will move on to our next speaker. But first, we have another poll question. So let's see if I do the, yep, there we go. Do you have a cybersecurity plan? It's a two-parter. And does it include a PNT data protection as part of that plan? So you have two questions, four possible combinations of answer. No, you don't have either. No, you don't have a cybersecurity plan, but you do have a plan for resilient PNT, or the opposite. You have a cybersecurity plan, but no plan for PNT data protection, or yes, you have yes to both. And you can say yes, even if you have two separate plans, or if they're all in one plan, but if you've addressed both of them, that would be a yes, the fourth one. So give you another few seconds to reply. Once we have most of the replies in, we will post the results, and looks like we have the results. And yes, oh, look at this. We have about half of you have a cybersecurity, no, in fact, about 3/4 of you have a cybersecurity plan. And about 1/4 of you, about 1/5 of you have at least some PNT data protection. but most do not. So I think I'm glad that you're here. Glad this is you went to the right webinar if you want to learn more about adding a PNT data protection plan to that. So Jim, I'll turn it over to you and we can learn about what NIST has been doing.
Thanks a lot, John, and thanks again to Orolia and for all the people who have joined, giving me the opportunity to present what NIST has done and continues to do actually in regards to the NIST PNT profile. Just a quick mention, my colleague Yashian Lebaboud is joining me and she'll be helping to answer some of the questions that are coming at the end, and I'll be doing the presenting on this one. So I'm going to credit Ernest with giving me a nice setup before we get into this. Real quick here, there's just folks, there's a little bit of a delay in the slides, so I'll be talking about things. Just to let you know, the document itself, NIST IR 8323, the Foundational PNT Profile, actually applying the cybersecurity framework to position, navigation, and timing services. What's important about that title is that you're taking a look at PNT from a cybersecurity perspective. In the executive order, there we go. Okay, everyone should be seeing the title slide I have up, NIST IR 8323. Okay, we're on to the next one. In the executive order, I'm going to reiterate a little bit of what Ernest discussed before, just to be able to provide a common flow for you to understand what it is that we took out, or I should say NIST took out of the executive order itself. So we're getting to a little bit more of a granular level here, focused on the tenets of the executive order. Responsible use of PNT services, deliberate risk-informed use, so that if disruption or manipulation were to occur, it would have a minimal impact on national security, and also, completely focused here, I should say, on critical infrastructure. I would say the best way to look at this in terms of the interpretation of the executive order is that it pertains to all end users. Part of the whole rationale behind the EO was just essentially to create a higher level of awareness. As you well know, GPS, GNSS is ubiquitously deployed throughout many infrastructures, and some folks aren't even aware that they're using it. So keeping all that in mind, we had this giant set of things that we needed to cover in terms of putting out a profile to help these end users mitigate some of the concerns, and also just, if for anything else, just to increase the awareness of the fact that you are using PNT and may not be aware of it. I would suspect most of the folks on this call are highly aware of that, perhaps a little more sophisticated use overall, but generally we had to make the public well informed about the fact that chances are you are using PNT services. Now, with that background in place, there were two particular sections of the executive order that Department of Commerce / NIST was responsible for delivering on. Obviously, we're talking about the PNT profiles here today. The executive order was submitted, or I should say published, on February 12th of 2020. I'll go more into the timeline in a couple of seconds here. And then Section 4, Implementation Part G, GNSS independent source of UTC within 100 days of EO release. So the first one, the profiles, was handled by a separate organization at NIST, and the second one was handled by our timing folks. With that said, both of these have been accomplished. Now, drilling down into the profile itself, the NIST 8323, the EO mentions profiles, and this is important to remember because I've gotten a lot of questions from folks about how come there's only one profile. We set up a single foundational profile based on the NIST cybersecurity framework. So we're covering cybersecurity, and we have a profile that other sector-specific agencies or members of the private sector, whomever, can take and adopt, and perhaps one of the longer-term goals in the executive order was to create their own sector-specific guidance on PNT specifically. So I'll get more into how cybersecurity and PNT overlap later on in the presentation, but for all intents and purposes, this is how we deployed what we were responsible for in terms of NIST, in terms of creating the profile for NIST, or I should say for all users. So the process itself, As you may well know, NIST really doesn't do anything in a vacuum, so it's open, transparent, and collaborative. This is just one of our mantras. So we'll start with engaging with primary stakeholders. In this case, as I mentioned, primary stakeholders are anyone using PNT services, focusing on the critical infrastructure and leveraging the cybersecurity framework. So I'll go into detail here, a little bit of detail in terms of the cybersecurity framework once I cover the timeline. February 12th, 2020, the executive order is published. In May, we issued the RFI, so open, transparent, collaborative. So we do a request for information. We got a tremendous response from the constituency. What this led to over the summer was assimilating all those responses and creating what we called a draft annotated outline to give interested parties a look at what we thought, based on the information that we had received in the RFI, what they could expect to see in a profile. So between that time, between August and September, we did host a workshop and presented many of our ideas there, gathered more feedback. That was in early September, and by October 22nd, we issued the draft PNT profile. Comment period was about 30 days. We're in a bit of a time crunch by then, so we got issued a 30-day comment period, and then finally, all throughout the holiday period, as Yashin can attest to, we worked on adjudication of the comments and issued the final PNT profile on February 11th. So this is what we're working with right now. The purpose, as you can imagine, there's multifold purposes to this, but these are the ones that I'll highlight here for this particular audience. Provide informed guidance to increase the responsible use of PNT services. That's a rather obvious one. Apply the CSF in the context of PNT data use and resilience. Again, this harkens back to everything that Ernest presented on earlier, and help organizations develop sector-specific profiles. We basically were attempting to set up the capability or the ability for perhaps, again, I say sector-specific agencies and or members of the private sector to develop their own PNT profiles. As mentioned earlier as well, prioritize PNT-related cybersecurity measures in accordance with business or mission objectives. It's all based on risk. What we do in the profile is highlight every profile that's out there is going to pertain to an entity's particular business or mission objectives. So if you can use the profile that's out there, and we're sure you can in some regard, or if you choose to create your own profile, it'll always relate to the mission or business objectives pertaining to a particular sector, subsector, or even individual entity. So that's really important information to know as and if you delve into the profile itself. Bear with me for 1 second here. I just clicked. So in terms of the scope of the profile, everything to the left is what we took into consideration. We have very little control of over to the right with ground segment signal origination and space segment signal origination. So everything that receives these signals was in scope for us. On the profile. You can read all about it. It's in the front matter of the profile. I don't have any of that here. I'm going to talk about basically the tables as they pertain or how to look through the cybersecurity framework. So here's where we get to the CSF, which it'll be called from this point on. Recover, identify, protect, detect, and respond. It's common and accessible language. By now, the cybersecurity framework has been out for about 6 or 7 years. It has gained widespread adoption, and in and of itself, it helps with profiling risk, I would say, in any environment. Again, from highly sophisticated users to medium-sized users, whatever the case may be, the CSF provides us a nice methodology, or provided us, at least in terms of the creation of the profile, a nice methodology to carry forward and develop a profile. Getting a little bit more into detail, those colored tabs there, those are the 5 main functions of the cybersecurity framework. We get into some further detail here as soon as the slide changes. There's like a bit of a delay here, so it should be coming up just in a second. We get into categories and subcategories, which further helps delineate the requirements that are present in the cybersecurity framework. There we go. So under the category of under the function of identify, perhaps you have asset management, business environment. Then we take that a step further into subcategories where we put out language, and then over to the right, perhaps one of the most important things that can be viewed as far as the profile is the actual mitigation guidance policies. Directives. NIST 853 is in there. This is in the maiden form of the cybersecurity framework, but we're going to get a little more into a little more specificity here in terms of the PNT profile. So the way it's crafted, you take your cybersecurity requirements, your business objectives, fully understanding what your technical environment is, and then what you see below: identify systems, networks, identify appropriate PNT services, detect disruption and manipulation, and manage the risks associated with all that. Those are all the 4 key tenets of the executive order. So that's exactly the approach we took to the development of the profile. And here you are taking a look at the very first control, I will say, in the profile itself. This is in the table. Again, there's a few pages of front matter giving the basis, background, explanation, rationale of how we went about things, but this is the actual practice of the profile, I will say, in and of itself. The function is identify, category asset management, subcategory AM1. There's the CSF language over to the left, and here's where the real work began for the team and I, and for everyone who participated. Its applicability to PNT. This is where we put in our language, based on the feedback that we had received from the RFI and all other inputs, and created over to the right a PNT specific list of references where you could go to get mitigation strategies and things of that nature. So at least one of the questions we'll be answering here is based on taking a look at this profile and applying the information in these PNT specific references based on the guidance that was out there. So it was not only us developing how this particular subcategory applies to PNT, but also finding references and information that could guide readers and users to potential mitigation or further develop their risk assessment profile for their own entity. I'm just about at the end here, so just a couple of quick things. I want to talk about outcomes really quick. NIST IR 8323, as you know, I mentioned already, submitted on, or I should say published on February 11th, 2021. The profile itself, as far as NIST is concerned in regards to the profile, as per EO 13905, it's a 2-year cycle. We will update it at least every 2 years or on an as needed basis. So I think, within the next 6 months, we should be developing some efforts to start taking a second look at it and see what needs to be modified or changed. I don't think it's been out there long enough to get enough feedback to say, hey, these are some of the changes that should be made, but we'll undertake a similar process to do those updates. I've received personally, and my team has, numerous inquiries regarding industry, sector, subsector profile development. One of the common questions, and this was alluded to earlier, cybersecurity profiles, or I guess the polling question was, do you have a cybersecurity plan, and does it incorporate elements of PNT? My suggestion is, if you have neither, you can do both at the same time. You can have, if you're already familiar or have cybersecurity plans and whatnot, it's shouldn't be too hard, depending on the level of use or dependency you have on PNT, to incorporate elements of PNT into that particular plan. And then finally, this name may sound familiar to you. It's another part of DHS. CISA, Jim Platt and I are going to be presenting at RSA on PNT resilience. So you'll see that, I believe it comes, we're going to pre-record it. RSA is all pre-recorded this year, and I believe the actual talk will be published on May 19th. The times are subject to change. They're in Pacific time, but you can expect to see a lot more visibility on the efforts that the federal government is undertaking. So Jim will be presenting from a very high level, the purview that DHS has over the whole program, or I should say, in as it relates to the executive order, and myself, basically reiterating the profile. And lastly, folks, just so you are aware, I've provided some links here for you The first one is direct access. It's a direct access link to the profile itself. The second one sends you to the GNSS independent time source. That's a link there for you if you want to inquire more about it. I believe it takes you to a place where you can submit questions. And then most important, in terms of answering direct questions from the user base, pnteo@list.nist.gov. There is a team of people staffing that that particular mailbox, and we all look at the questions that come in. I encourage you, whatever questions are not answered here directly for you today, to take advantage of that, because you will get a response on that. And with that, John, I am finished, and I'm going to turn it back over to you. Thank you.
Great, thank you, Jim. Very, very interesting and very impressive with the amount of work that you folks got done in really amounts to a less than a year kind of thing with a brand new initiative. And one thing is said, if folks will look at this, the foundational PNT profile on this link that you give, folks will see that it's really a lot of comprehensive work. So I guess maybe we have the pandemic to thank that, you couldn't go out and have any fun. You got some work done. So we're glad.
Got a lot of work done. Thanks, John.
Got a lot of work done. Thank you. So, okay, we'll move on to our next speaker. But first, I think we have another poll question. So there we go. Which critical infrastructure do you think should be the most concerned with resilient PNT? And so we've got 5 choices there for you. I know there's a lot of different critical infrastructures. I think actually DHS had identified, I think 16 or some there. We don't have enough room in our poll question to ask more than 5, so we kind of grouped them this way. So if you could just pick the one that you think is the most. This is just maybe an interesting little exercise to see what our audience thinks. I think we probably all have our own opinions, especially the area that you work in is usually the one that you think is the most important, but it'd be interesting to see. So we'll just maybe give it another few seconds to see how people are responding, see if we can get a good thing, see if you're still listening to this webinar and clicking and listening, maybe only listening with one ear, but if you could get your results in, and looks like we've got some results. And so, yeah, I guess power grid, industrial control, almost half of you think that thing, the utilities. About 1/5 are saying telecom, data centers, financial, those areas, transportation, a little more than 10%, about 10% don't know, and then there's others. So, okay, looks like we have that. And so, great. I think that's a good lead in to Jerry. Jerry, over to you. Let's hear about your work. And Jerry, looks like you're unmuted. So, but we're not hearing anything yet.
Hi. Well,
There we go.
can you guys hear me?
Yes, we hear you now. So great. Over to you.
Okay, thank you. So I want to thank Orolia for the invitation to this PNT Coffee Talk. Again, my name is Jared Trevino, and currently I work as a 5G network engineer in cybersecurity with the Joint Base San Antonio 5G Next Gen PMO team. And we're working on some really exciting 5G related experimental projects that are being done at the Department of Defense. And today I will be sharing some of our related activities, especially on how they relate to PNT. So a little bit of my background, just looking at the polling. For the last several years, I have conducted some activities around PNT testing in the power industry. As it turns out, actually, the power industry, you can consider them as well very reliant on telecommunications. So you can kind of combine those two elements, because not only do they have to monitor power and kind of have a high level of resiliency on that end, but they also rely on telecommunication technologies to share information and maintain the grid. So, you know, this is an area that we have done significant testing, and we've been engaging with the Department of Homeland Security and with NIST. So there's actually SEAL work being done at EPRI There's right now work being done in terms of producing. They recently produced a roadmap to resilient PNT as well. There's continuing efforts testing some of the solutions, what I call PNT solutions. So it's exciting to see the progress in this area, not only from I will say these efforts that our leaders in the government side are taking on, but also how the industry is looking at taking those and implementing them. So in my current role, again, I'm going to be focusing a little bit more on telemedicine and cybersecurity. So those are the kind of topics that we'll be discussing today. Right now, the agenda for this presentation will only include some of the actions and priorities that we're taking so far. This is a very recent set of activities that we're conducting. So for those that don't know about it, the Department of Defense has recently released a 5G strategy implementation plan. Basically, the Department of Defense considers 5G as a critical strategic technology and has developed a 5G strategy implementation plan, which again was released in 2020, December 2020. Again, this is a publicly available document, so if you haven't seen this, I recommend that you take a look at it. See if you haven't done so. The Department of Defense implementation plan, 5G implementation plan, delineates 4 lines of efforts. Our projects at JBSA play a key role across these lines of efforts. So in the next slide, I will share a closer look into how precisely these efforts relate to our 5G projects. So within the plan to promote technology development, the Department of Defense is working under the leadership from the Office of the Undersecretary of Defense for Research and Engineering, or what we call OUSD R&E, to host 5G demonstration projects. Joint Base San Antonio was selected to lead projects in 5G core security, 5G telemedicine and training, and the implementation of a 5G testbed, which is going to be located at Joint Base San Antonio. Actually, these are going to be also solicitations, and they're expected to be available through the National Spectrum Consortium. So if you are interested in learning more about these projects, or if you have your company is interested in responding to some of these opportunities, I encourage you to visit their website for more information. Again, it's the National Spectrum Consortium, and I believe there's some membership that is going to be available as well for that. So next, I will share another implementation area specific to dealing with potential security issues. Again, this is all part of the strategy that DoD has set forward. So in this line of effort, the 5G implementation plan identified 5 areas of interest, including the need to minimize 5G infrastructure risk and the recognition of implementing a zero trust approach to 5G vulnerabilities. So the question is, what is the relationship between position, navigation, and timing and 5G vulnerabilities? And we'll briefly touch on that, but wanted to share this framework and strategy. So in relation to 5G, it is important to recognize that it's not just a simple step evolution of 5G networks, of 4G networks, but rather a leap forward in how new applications will leverage 5G to deliver new mission capabilities. So 5G includes use cases in addition to the enhanced mobile broadband, and include also massive machine type communications, typically related to IoT applications, and the capability to connect a large set of industrial devices under the network. Another key use case is the introduction of ultra reliable, low latency communications. 5G also allows for the end user application to leverage these use cases and adopt URLLC and EMBB use cases. And that's kind of something that is going to be remarkably different from what we known to be the capabilities for 4G. So it's not only having more bandwidth, but having these more customizable networks. And the third generation partnership project, or the 3GPP, is one of the main organizations providing 5G standards and recommendations. Our team is currently focusing on release 16 and release 17, along with other related standards coming out of these efforts, including the IMT 2020 and other documents. And some of these documents bring this notion of key performance indicators, which I believe is going to be critical to ensure the Department of Defense capabilities are enabled by 5G are actually realized. So within this context, you can see in the image here that literally these 5G applications can be architected to have not only one set of capabilities, but they can have a mixture of them. So that's again due to the nature on how 5G is going to be flexible. And 5G network synchronization will be supporting these applications through standards such as the ITU-G 8272.1, which introduces an enhanced primary reference clock with upgraded performance and also time distribution protocols that we know about, like IEEE 1588. And again, these are expected to be used extensively in 5G. So this is going to be a very important topic in 5G. So I will also want to share one specific use case that our team is looking at in telemedicine. We're starting to investigate how 5G can be used for remote telerobotic surgery, and more specifically, how 5G could leverage ultra reliable, low latency communications to enable doctors to perform surgical procedures in forward settings. So for this to happen, resilient PNT will be needed. And with that, you will bring the associated vulnerabilities that these systems will inherit. So how to deal with this and how to make these systems more resilient and be able to fight through some of these events is going to be a focus for our team. So some of the actions that we're taking to deal with this is we're very closely tracking developments coming out of DHS and NIST as it relates to PNT Conformance Framework and the Foundational PNT Profile. We're also considering some of these concepts in our 5G experiments. I will say our priority is to use these experiments and inputs from emerging concepts such as zero trust architectures and input from stakeholders such as the group meeting here today to develop a reference architecture for future 5G systems that will be used in the Department of Defense. So with that, I want to thank everybody for your time, and John, you can take it from here.
Great, thank you, Jerry. Thank you, and that's really interesting to hear. You really seem to be a practitioner of what we had heard earlier from DHS and NIST, of where you're putting this into practice, and especially to get ultra reliable, low latency stuff. To be ultra reliable, it has to be secure. So that's great. So very good. We'll move on to our question and answer period soon. But first, we do have a couple updates from Orolia. There we go. We'll give you a few updates of what we're doing in this area. So in the first area, I guess there we go. If I can get the screen, a lot of latency here. Maybe we need to work on low latency ourselves here. The Orolia is part of 16 and a growing number of companies that have joined the Open PNT Industry Alliance. This group mission is to promote an open marketplace of concepts to really protect GPS, GNSS, multiple solutions that are the most technologically advanced, commercially available, and based on a sustainable long-term funding framework. So it's this group of companies were really endorsing the government's work. Most recently, the Department of Transportation had done a report on PNT of some of the alternatives, what things could be done to make it more resilient, and also is the work that you just heard from DHS and NIST and even the DoD of advancing the government-led initiatives. So we get questions all the time how we can, companies that want to join us in this. There's a number of companies there, but just go visit our website and see how you can contribute as well. So that's that on that. We'd also like to, today we're announcing a new tool. We're calling it RESI, the RESI PNT report card. It's the Resilient Excellence Scoring Index. As some of you have looked at these, the framework, the PNT profile, these are pretty very comprehensive, very extensive amount of documents to go through. So we thought we'd create a nice tool that you can take a short survey, complete in less than 5-10 minutes, and get an assessment. When you'll receive an assessment of your environment, what you're doing well, some recommendations on what you could improve on, and help you to prioritize things and stuff. So it's a score out of 100, and you'll be able to measure yourself. So those of you that are registered for this webinar, you'll, in the email response that you'll get, you'll see how you can do this, and hopefully you'll find this as a useful tool. So so with that, I think we'll move on to the question and answer period. Oh, we have, I think, one more polling question for you folks. I think we'll call that up next. Yeah, question number 4. So let's see, that's the previous question. We're gonna go up to the next question is, okay, would you like some information, someone from Orolia to contact you? This is a simple yes or no. We won't wait for any response on that. You can respond to things, and we'll get on with the question and answer period. So I have a bunch of things here. We only have a few more minutes, so let's get to it. First question is, do you consider GPS signals traceable to UTC? If not, what would you be required to satisfy a requirement for this traceability? So I think this would be best for NIST. Turn it over to you.
Yeah, thank you, John. This GPS signal in space is traceable because the U.S. Naval Observatory monitors the transmissions, and also the satellites broadcast the predicted parameter values to allow a receiver to estimate the offset between UTC USNO and the transmitted time. However, to satisfy technical traceability requirements for accuracy of GPS user equipment time outputs, an organization would need to provide a documented, unbroken chain of calibrations from a realization of the UTC reference to the GPS receiver's local time output. At a minimum, the user would need to calibrate and document the path delay and path delay uncertainties between the source of the time signal and the user equipment's time output, as well as the uncertainty of the user system calibration. Uncertainty can be classified as type A, which is characterized using statistical analysis of measurement dispersion, such as time deviation, or as type B, such as cable delays, which can be characterized using a measured constant. The actual documentation required depends on the organization or sector's regulatory and technical traceability requirements. In general, it is the user's responsibility to calibrate, monitor, and document the measurement uncertainties of the user equipment links, including GPS equipment such as antenna, intermediary components, cables, receiver, and downstream links that propagate or use time signals that are dependent on GPS as a reference. Full traceability to UTC USNO can be established a few days later when the U.S. Naval Observatory publishes the measured offset between the time broadcasted by the satellites and UTC USNO timescale. Satisfying traceability is a part of responsible use, and there is guidance along with the informative references in the PNT profile as part of understanding of the governance and having the proper maintenance and documentation procedures in place. Traceability is especially important as requirements emerge with greater criticality and demand for accuracy, with the existence of RF interference and spoofing threats, as well as jamming, and other environmental and local issues that can arise and affect the accuracy of the user's time distribution system. While GPS signals generally have small enough uncertainties to meet accuracy requirements, ultimately it is the responsibility of the user to provide sufficient evidence that their time distribution system meets the traceability requirements. We're ready for the next question.
Great, thank you, Yoshi. And I guess that, as we see, there's not a simple answer to that question, which I did not realize, because I always thought, oh yeah, it's traceable to UTC if you use GPS. But I think what I heard there is yes, the answer is yes, but there's a lot that you have to consider, and to keep that unbroken chain and some procedurally to keep it there. So thank you. Yes. Next question is, for stationary platforms or those with IMUs, what role might extended periods of reference sampling have on resiliency? So Ernest, would you like to take this one?
Sure, John, thanks. And thanks for this question. I think this is getting at the concept of not always disciplining your clock or your IMU with this extended period reference sampling. And that's a really good concept to be using, because this does tie back to the resilient architecture concepts in the earlier slides of my presentation. And that really is the best way to do things. You know, if you can characterize and understand the performance of your holdover device and also compare it against your operational requirements, then you really should be able to only oscillator on an as-needed basis. And this will help limit your exposure to that attack surface, or really you're limiting your attack window. So that definitely is something that we'd encourage when it comes to having a way to get external PNT sources resiliently. Thanks, John.
Great, yeah, like you said, you know, you wouldn't leave your ports open all the time in a regular IT system, and this equates to that, so that makes sense. Great. Next question. I just want basic fundamentals for GNSS anti-jamming protocols. So NIST, maybe that would be one for you.
Yeah, sure, John. Thanks for the question. And to the individual that asked that, I'm going to list specific references in the profile where you can go to obtain that information, rather than giving you the specific protocols, which really is not my decision to make on your behalf. These are areas in the profile itself where you can reference information, perhaps pertaining to specific protocols that may assist you with this. So again, when I call out these code numbers, these relate directly to the profile that I outlined in my presentation. So first and foremost, this, take a more comprehensive look at this. RA1, RA3, RA5, MA1, CM1, CM8, and RP1 and CO1. Okay, so those all pertain to, as I mentioned, in the cybersecurity framework, we have these breakdowns of function, category, subcategories. What I just named to you were the subcategories where you can go in the profile to obtain that information. And as I encouraged before, I encourage again, any questions of this nature, if this wasn't satisfactory, can be sent through that pnteo@list.nist.gov email address, and you can be sure they will be answered. So I hope that was helpful to the person posing the question. On to the next, John.
Yes, okay, great, thanks. I'm sure it would be helpful. Okay, next one I have is, which security is more relevant? Jamming, spoofing, or cybersecurity for GNSS receivers? And then the second part of that question is, does DHS have a monitoring system? So I guess that general question, maybe we could hear from everyone on that one. And then the second part is really to DHS. So I'll leave it open. Who would like to start?
I can take this, John. This is Ernest.
Great.
This is an interesting question, really a good discussion question. And I think there's two parts to this. So jamming and spoofing, cybersecurity, I think there's some mixture there, but they all are important. Though from the perspective of an operator, if you don't know, so jamming is pretty easy to detect, the spoofing not so much. So if you don't have situational awareness, I'd argue that spoofing is more of an issue, more of a threat, because if you don't know what's going on and you're making faulty decisions off of that, potentially, if you're making decisions off potentially faulty information, that can have some serious consequences. So I'd argue that spoofing is probably more of a threat. As far as the second half of the question, there is a federal interference reporting process. It starts within the Coast Guard Navigation Center, and then it goes through the emergency process. But I think this kind of gets at something a little bit deeper, which is the question of what sort of monitoring system should we have? Is it localized? Is it national? What should it be? I think with the presentations, discussions about those next-gen resilient PNT concepts, one of those assumptions is that we have to assume that systems will be attacked and to be able to withstand and operate through them. So that kind of moves the importance of detection and situation awareness down to the localized receiver level. And ideally, if you follow all these architecture design principles, you should be able to operate through that threat. So in the ideal receiver, there would be interference and you wouldn't care. You would just keep going. So that would be where we want to get, I think.
Makes sense. Makes sense. Okay. Anyone else want to comment on that? I'm looking now. We're at the top of the hour. We're actually out of time. So I think we're probably going to have to stop there. If we have other questions, we'll try to address some of them to you each personally by email, some of the ones that you've asked if we can. So I think with that, we'll have to call it a finish. I want to thank all of our speakers from DHS, from NIST, and from the DoD for sharing this lot of valuable information. I hope you all found it as valuable as I did, and we'll look for you folks to join us the next time at one of our Coffee Talk webinars. Thank you, everyone. Have a good day.
Thank you, John.
Thank you. Goodbye.